Here we have problem 9.32, and we're going to see the difference between sampling from a population, which we have here with this bell curve, and then sampling from a sampling distribution. So part A asks, what is the probability of getting one individual, a single student, from this distribution? And in order to solve that, we need to look at the z-score. Or you can use a TI-84, but I am doing this the traditional way, which is, what would this z-score have to be? Okay, so in order to do that, I did a little work underneath here. We'll say, well, the z-score is going to be the distance from the mean, in this case, 21 minus 18.6. These are ACT scores, and the average here is 18.6. 18.6. So, I can't get, there we go. So where is 21? Well, it turns out 21 is less than 1 standard deviation to the right of the mean. It is above average, right? But if we divide this by, by our standard deviation of 5.9 that was given to us, we get a z-score of 0.41. And it's this z-score that tells us how much area is either to the left or to the right. And if we look this up, this is about 34%, 0.3409. Now, how does this change when we talk about a sample? What if we looked at a sample of 50 students? This is part B. Part B is going to be using some different numbers. They ask us, well, what would your mean be? Well, the sampling mean is expected to be the exact same as the population mean. So we expect 18.6 again. However, we're also expecting a much smaller standard deviation. The standard deviation of these means should be the 5.9 divided by what? Divided by, problem with Doceri here is I can't make decimal. Divided by square root of 50. Well, this changes the story. Our curve is going to be much taller and much less spread out. This ends up, when you divide 6 by 7, you get something which is, roughly, that is 6 divided by square root of 49. So this is 0.834. Well, that tiny standard deviation is going to change the shape of our curve. We still have 18.6 in the middle here, but we now have a curve that looks more like this. Our sampling distribution is not likely to have values over 19 or under 17. And so when we calculate a z-score with this, this is part C, the probability that your sample mean, given a sample size of 50, is greater than 21, well, that's going to be a different story. It's the probability that z is greater than what? Well, this z-score is going to be quite different. When we put in the 21 minus 18.6, we're dividing by this tiny 834, and that gives us a z-score of 2.88. And let's just change this for a second. We'll put in, what was the difference? Here we had a z-score of 0.41. Here we have a z-score of way over 2.88. So that's going to cut, something like over here. and we just have this minuscule little bit of area here, which on the table is 0.2%. That's the probability of getting a score of, and that this is an average, right? An average score of 21 or higher with a group of 50. So again, what's the difference? We have here a individual could easily land, 34% chance of getting 21 or higher. But a sample of 50, not likely. The sample of 50 we're expecting to be in here, 95% chance that we're really close to 18.6.